लॉजिक सर्किट्स क्या है? By combining different logics, okay, we can perform many functions. Okay, we can make many functions, many things. Okay, so the example of combinatorial circuits are half adder, full adder. Okay, so adder circuits, subtraction. Okay, then encoder, decoder. Okay, multiplexer, okay, parity checker, etc. Okay, so these are circuits, okay, which do not contain any memory element. So basically your digital circuits, okay, your digital circuits are two type. Okay, one are called combinational circuits, okay, or non-sequential circuits, and one is called sequential circuits. Okay, non-sequential circuits also called this your combinational circuits. Okay, combinational circuits. So these circuits do not have a memory element. Okay, so we can design, okay, many circuits with this. Okay, like a half adder, full adder, half subtraction, full subtraction, encoder, decoder, multiplexer, parity checker. And the sixth topic is sequential circuits which have memory. So this will be covered after combinatorial circuits, sequential circuits. Okay, sequential circuits we will discuss flip-flops. Okay, flip-flop is a memory element. Flip-flops, okay, counters, then shift register. All these things will be discussed in sequential circuit. Okay, and the last topic in digital circuit or digital electronics, which is your syllabus, that will be your A to D conversion, and D to A conversion. Okay, analog to digital conversion and digital to analog conversion. So basically this is your all the content of the syllabus. So if you're in doubt about this content, you can ask me, and we'll start today with this number system. Okay, all of you know what is number system, but just for completeness, let me start with the very fundamental of this topic. तो किसी को कोई डाउट है क्या कंटेंट में? Okay, can I erase this one? So I'm erasing this. Yes. Okay. So put the heading now. Number system. So in this course, basically we will discuss 4 type of number system. One is decimal number system. Okay, in decimal number system we have 10 symbols, okay, or 10 digits. So it has a 10 digit 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, So that is also, it is called base 10 number system. Base or radix, okay, is equal to 10. Okay, so this is called base 10 system. Okay, the base of this number system is 10. Similarly, the second number system is binary number system. Okay, and this number system has two symbols or two digits. Okay, that is 0 or 1. Okay, and the base of this number system is 2. What is the base? We'll discuss now. Okay, let me give first the 4 number system which we are going to use mainly in this course. And the third number system is octal number system. Octal का मतलब है 8. Okay, so this number system has 8 digits or 8 symbols to write any number. So you have 0, 1, 2, 3, 4, 5, 6, 7. Okay, so right, using this symbol you can write any number in this number system. Okay, decimal you all are aware. Okay, we use the symbol from 0 to 9. Okay, in binary number system any number can be written in terms of 0, 1. Okay, as an array of 0, 1 you can write any number. Similarly, in octal number system you use only this 4, 7, this 8 symbols to write any number. Okay, so you can represent, okay, any number in these number systems. And the last is your hexadecimal number system. Okay, hexadecimal number system has 16 symbols. Okay, so 0 to 9 are same like decimal. 1, 2, 3, 4, 5, 6, 7, 8, 9. After 10 you write alphabets. Okay, instead of 10 you write A, then B, C, D, E, F. Okay, so for 10 you write A. Okay, similarly for B for 11, C for 12, D for 13, E for 14, and F for 15. So total including 0, this system has total 16 symbols or 16 digits. Okay, so base of this is 8. Base of this number system is 8. Base of this number system is this 16. Okay, now what do you mean by this base? So let me give you example. So any number, okay, regardless of any system, any number has 2 parts. Okay, any number can be written as, say, dn, dn minus 1, dn minus 2, okay, d2, d1, d0, and you can write d minus 1, d minus 2, d minus 3, so on. Okay, so any number, okay, so this is any number, representation of any number. Any number in any number system can be written like this way. This is your integral part. Okay, integral number or integer, you say integer. Okay, integer, this is your integer part, and this is your decimal. Okay, and this is your fractional part, fractional number. This is your integer number and this is your fractional number. Okay, so any number, okay, any mixed number. मिक्स का मतलब क्या है, उसके अंदर इंटीजर नंबर भी है और उसके अंदर फ्रैक्शनल भी है. दैट इज कॉल्ड मिक्स्ड नंबर. ओके, दैट इज एनी नंबर और यू कैन कॉल एनी मिक्स्ड नंबर can be represented in this way. Now for example, if I have a number, say, let me write a number 92, okay, 56.26. Okay, this is a decimal number. So how can I write this number? This is a decimal number system. So I can represent this number as, okay, as 9,000 plus 200 plus 50 plus 6. Okay, and then I can also write 0.2 plus 0.06. Okay, can I write this number like this?
Yes, sir.
Yes, sir.
Okay, so now same thing, if I write this number as like this, I can write this as an n 10 power 3, okay, 2 10 power 2, 5 10 power 1, 6 10 power 0. Okay, yeah, 30, so I'm putting 10 to the power 3, 20, I'm putting 10 to the power 2, 10, I'm putting 10 to the power 1, no 0, I'm putting 10 to the power 0, that is multiplied by 1. Okay, 10 to the power 0 is 1 multiplied by 6, and then you can write this as a 2 into 10 to the power minus 1, and you can write 6 into 10 to the power minus 2. Okay, and if there are further numbers, you can keep on writing like this. Okay, so that means this 1000, 100, 10, 10 power 0, that is 1, 1 by 10, that is 0.1. Okay, 10 to the power minus 2. Okay, these all things, okay, these all things are what? They are the weight of the position. Okay, so every position, okay, generally this is your the left side, that the digit which is left side, which is called your MSB, and this is your LSB. Okay, so if this is not fractional, okay, so for the moment forget this one, MSB, LSB, we'll talk later. Okay, so now, so what I'm writing here, these are the weight of these positions. Are you getting my what do you mean the weight? Okay, so weight of this position, so this is a first position, the weight of first position is 1. Okay, so the weight of second position is 10.
Sir,
The weight, yes,
the video is lagging.
okay, yes, okay, so I'm repeating again what I'm writing here. This is the 1000. Okay, the 1000 is the weight of this position. So this position is the weight 10 to the power 3. This position is the weight 10 to the power 2. This position is the weight 10 to the power 1. This point is a weight is 10 to the power 0. Okay, and this after decimal, this digit, this weight, this position is the weight 10 to the power minus 1, and this position is a weight 10 to the power minus 2. Okay, so if any number, okay, so this is a decimal number, writing way of decimal number system, and it is base. So if there is any number, I can convert that number into a digital number by writing in this way, if I know what is the base of this number. Okay, for example, suppose I have a binary number, okay, 101, okay, 01. Now I want to write its decimal equivalent. Okay, so in order to write the decimal equivalent of this number, I should know the weight of this position. Okay, so this is the first position, so this is the weight will be 2 power 0. Okay, second position will weight have 2 power 1. Okay, so the weight of, let me write a little bit bigger, so this is 1 0. Okay, 1 0 1. Okay, so if I want to convert this basic binary number into decimal number, so what should I do? So just I need to multiply. Okay, so this is 0 1 2 3 4, so I have to multiply this 1 by 2 power 4. Okay, 0 by 2 power 3. Okay, again 1 by 2 power 2, 0 by 2 power 1, and 1 by 2 power, okay, 0. So if I solve this one, what I'll get? I'll get 16. Okay, 16 plus 8, 16 plus this 0, 16 plus this 4. Okay, and I'm getting this 1, I'm getting 21. Okay, so what you need to do if you want to convert any binary number into decimal number, just to write their weight. So the first position weight is your 1, second position weight is 2, third position weight is 4, fifth position weight is 8, sixth position weight is 16. Okay, now you have to multiply this number. So wherever there is a 0, that you cut that number. So this is 0, this weight has a 0 weight, 0 multiply 0, so cut this one. Remaining you just add 16 plus 4 plus 1, 21. Okay, so the binary decimal equivalent of this number, so 0 1 1 0 1. Okay, a decimal equivalent is just 10. Okay, so in this way you can write any number. Now for example, if a number here I use the binary number, instead of binary number there is the octal number. Okay, or there's hexadecimal number. So you know octal number has a base 8. So you can instead of multiplying to power 2 base 2, you have to multiply this number by power this in terms of base 8. Okay, similarly if there's there's a hexadecimal number, and if you want to convert in decimal number, you have to multiply each digit by its positional weight. Okay, like here is 2 power 0, 2 power 1. In octal that will be 8 power 0, 8 power 1, 8 power 2, and hexadecimal similar same thing will be 16 goes as like that, 16 power 0, 16 power 1, 16 power 2. Okay, so you can convert this way any number to decimal number system. Okay, now this was your integer number. What about if there is a fractional part also there? Okay, so this is only integer number. Let me write a mixed number. Suppose now I have say 1 1 0 1 1 1 1 point 1 0 1 0, and I want to convert this number in a decimal equivalent. Okay, so what is the decimal equivalent of this number? So I have this number which written in 11011.1010 in decimal. I want to write this number in decimal number system, decimal equivalent. Okay, the method is same. Okay, here the weight, you start with weight 1, weight is 2, weight is 4, weight is 8, weight is 16. Similarly decimal, the weight is what? 2 power minus 1, that is 0.5. Okay, then 1 upon 2 power minus 2, 2 power minus 2 means 1 by 4, that is 0.25. Okay, then 2 power minus 3, 2 power minus 2, 2 power minus 1, 2 power minus 1, 0.5. Okay, 1 by 4 is 0.25, 2 power minus 3 is how much? 1.25. and similarly the last one digit, okay, 2 power minus 4, 1 by 16. So 1 by 16 is how much weight? 1 by 16 is equal to how much? 1 by 16 is
0.0625.
0.0625. 0.0625. Okay, now just you want to convert. So wherever 0 is, you remove that number. Okay, so this become 1 plus 2 3, 3 plus 8 11, and 16, this become 27. Okay, decimal as it is. Here this will cancel out, this number will cancel out. So 0.5 plus 0.125. Okay, how much? 0.625. 0.625 and again 0, it is 0.625. Okay, so if I want to write the decimal equivalent of this number, it will be 27. Okay, 625 in decimal. Okay, so if you have a doubt, please ask. If this point is clear, how can you convert any number? For example, I have again example here, binary number. I have converted binary number into a decimal number. Okay, I can do it for any number system. Okay, just give me 1 minute. What is okay? So now suppose any number we can convert in decimal number. Now suppose if we have a decimal number and we want to convert in any other number system, like for example binary. Okay, so put the heading now, decimal to binary conversion. So decimal to binary conversion. Okay. So this conversion method is called successive division method. Okay. Successive division method, or also we call this as a double method. Okay, double method. So what is this method? For example, I want to convert 52 into binary number system. Okay. So what this method says, that you have to successfully divide the number by the base in which you want to convert. Okay, for example, here I want to convert in binary number system. So what I'll do, I'll divide this 52 by 2. Okay, so, and I will note what is the remainder. Okay, so suppose if I divide by 2, I'll get 26, remainder will be 0. If I divide 26 by 2, I'll get 13, remainder will be 0. If I divide 13 by 2, I'll get 6, remainder will be 1. If I divide 6 by 2, I'll get 3, remainder will be 0. And I divide 3 by 2, I'll get 1, and remainder will be 1. Okay. Similarly, if I divide 2 by 1, I will get 0, and remainder will be again 1. Okay. So now when you want to write a number here, okay, you have to go from, okay, from low to upper size. Okay, you have to go up. So this will be your MSB, this will be MSB, and this last number will be your LSB. Okay, so you have to go up. Okay, you have to go up. That means if you want to write 52, okay, so that will be what you write. This is a MSB. MSB means jiska weight sabse zyada hai. Okay, which is the term which is most important. So you can write like this is a 1 1 0 1 0 0, and this is your binary equivalent. Okay, the conversion of decimal number into binary number. Okay, you can check it again. This number, this system has a weight 1, this system has a weight 2 4 8 16 32. Okay, this will cancel out, this will cancel, this will cancel. So now 16 plus 4 20, 20 plus 32, that is 52. Okay, that is correct. So this method is called your successive division method, or you can also call it double method. Okay, now what about if there is a fraction? Okay, so this was a pure integer number. Now if it is a fraction, then how can I convert? Okay, so let me give you one example. So say if I have a fraction, say 0.85, okay, and this fraction I want to convert in decimal number system. So what should I do? So I just
0.85.
0.85. Okay, just what I want to know, I want to multiply, this time I have to multiply by this base 2. Okay, when I multiply by this 0.85 by 2, I'll get what? I get 1.7. Okay, 1.7. So this time you have to write what is the carry. Okay, so this is equal to 0.7, and you can write carry is 1. Okay, this is a fractional part. Again, take this fractional part, multiply by 2, this will give you 1.4. You can write fractional part here, and carry will be again 1. Okay. Again, you take 0.4 multiply by 2, that will give you 0.8. This is the fractional part, 0.8. So carry is 0 in this case. Again, multiply by 0.8. Okay. 2, you get 1.6. You get how much? You get here fraction 0.6, and the carry is 1. Okay. You can do it one more time. 0.8, 2. Okay. 0.6 multiply by 2, that will give 1.2. 0.2 is your fraction, and this is your carry. Okay. So basically there is a no limitation. Okay, you can keep on going until either you're getting repeating values, or you can keep you can do it this 5 or 6 times. The number of times you will multiply this one, that will increase your accuracy. Okay, like how to solve this fractional part, decimal part. Okay, we will not solve always for completely. Okay, so we'll solve up to 3 to 4 digits, and then we'll leave it out. Okay, so here also I can leave it out here. So say 0.2 is there, I can multiply, this will give me 0.4, so this will be 0.4, and this will be my fractional part 0. Okay, so while converting a fractional part into binary number, okay, now you have to go down. Okay, so this will be your MSB while writing this fractional part, and this will be your LSB. Okay, so if I want to write 0.8.5, so simply I can write 1 1 0 1 1 0, and this is binary. Okay, and this obviously is the point is there. So in this way we can convert any number system. Okay, here I have converted decimal into binary. Okay, if you want to convert binary decimal into octal, then instead of 2 there will be 8. Okay, you have to divide by 8, successive division by 8, and multiply by 8 fractional part. Similarly, it is a hexadecimal number. You have to divide this decimal by 16, and fractional part of the number you have to multiply by 16, and you have the same procedure you have to follow. Okay, then you can convert any decimal number system to any number system. Okay, now it is method is clear.
Sir.
Any question?
No, sir, it is clear.
Okay, so this is your
सर हेक्साडेसिमल का जो एबीसी नंबर है उसको कैसे कन्वर्ट करें?
बताएंगे ठीक है. डेसिमल टू बाइनरी नंबर सिस्टम. नाउ 1 bit. Okay, what do you mean by bit? Okay, so bit is basically binary digit. Okay, bit means this is the one binary digit. Okay. So bit is basically your one binary digit. So I write bit as x. Okay, so x can be 0 or 1. Okay, similarly if I want to write nibble. Okay, nibble. So nibble has 4 bit x. Again, x can be 0 or 1. Okay, similarly if I want to write a byte means the combination of 8 bits. Okay, one single digit is called bit. Okay, one single binary digit is called bit. Okay, the combination of 4 digit is called nibble, and the combination of 8 digits 4 5 6 7 8, combination of 8 bits is called your byte, 1 byte. Okay, so you have to remember your x can be 0 or anything. Okay, similarly if I want to write 1 kilobyte, so all of you know generally international 1 kilobyte means 1000 bytes, but generally the conventional way is to write this as a 1024 byte. Okay, 1 kilobyte means this is byte. Okay, so that's the 1004 bytes. Similarly if I want to write 1 megabyte, so 1 megabyte will be nothing, that will be 10 raised to about 24 kilobytes. Okay, kilobytes. and kilobytes is again, so this will be 1024 into 1024 bytes. Okay. Similarly, if you want to write 1 gigabyte, so 1 gigabyte will be your simply 10 raised to power 24 megabytes. So this will be, if you convert this in bytes, so you can write 10 1024 1024 1024 bytes. Okay. So you can similarly you can keep on going like this. So this is your basically memory. Okay. So this is a 1-bit memory. So this was your binary number. Okay. Now suppose if I want to convert 2 megabyte. Okay. So can you tell me how many? Okay. What is decimal equivalent of 2 megabytes? 2 megabytes. Okay. What is the decimal equivalent of 2 megabytes? Okay. So this is your homework. You tell me. That means 2 megabytes contain how many bytes? Okay. That is your homework. Now
here x is 0.001.
which is x?
X is 1 byte. You have written 8x.
If there are
8x.
if there are 8x are there, that is 1 byte.
And 1x equals to how much?
1x is 1 bit. Any number system
So,
is made.
Is there any value of x? Or
X
just...
can be 0 or 1, na? Binary number system.
Oh, okay, sir.
Okay.
Okay, sir.
So it can be anything 0 or 1. Okay. So before I go to another number system, okay, let us solve some problems.
In the previous question, which you have written before this, that how many bytes are there we have to
Yeah.
find?
Yes.
Okay.
Okay. So you have been given that, okay, 16 in base 10 is equals to 100 in base B. Okay. So you have to find the value of B. Okay.
2, sir.
2.
2.
How? Okay. So 16 is equal to, in some another number system, is equal to 100. So what is the base? Okay. So I told you, if you any number is given and this base is given, so 100 B means what? B power 0, B power 1, B power 2. So I can write like as a B power 2. If I want to convert this as a decimal number, this is any number system. I don't know what is the binary, octave. I don't know what number system is this. Okay. If I want to convert into decimal, I simply multiply by this by base. Okay. 0 power B power 1, 0 B power 0. Okay. And this is the decimal equivalent, and that is already given 16. Okay. So this will give me B square plus 0 plus 0, 16.
Base 4.
So base will be 4. B will be 4. Okay. So here I have written 100. That doesn't mean that is your binary number system. 1 or 0 is exists in every number system. Okay. Octal in octal also have 10. Hexadecimal is 10, but this you, so it should not be that if you want to write in binary.
But they're only binary and octal and hexadecimal only. There is no, sir. Number systems.
Yes. So this is no, that number system can be anything. It's not necessary decimal. You can define any base. Okay. You can write every number in base of 3, base of 5, base of 7. It's not necessary. Okay. That is a number system which is computer understand, which is used mainly in computer. Okay. The 4 number system which I introduced in the beginning. Okay. that is traditionally used. Okay, but in fundamentally you can define number system with any base. Okay, so now suppose determine the base in following operations. Okay, so you have been given 43. In some base 41 by 3 is equals to 13. Okay? In some base, I don't know what is the base. Okay, so in some base this is equal to 41 divided by 3 is equal to 13. Okay, in some base. Okay, find out the base. What is the base? Tell me.
Sir, both bases are to find, sir.
See, I'm telling you, in some base system, okay, when I divide 14 by 3, I get 13. Are you getting my point? In some base system, when I divide 14 by 3, this is not equal to decimal. In some number system, when I'm dividing like this, I'm getting this one. So what is the base? Okay, what is the base? So to understand clearly, I'm writing here base. Okay, so some number system, okay, when you're dividing, you're getting like this. So what is the base? So simple, you write every number in terms of base. It's a 41. So 41 you can write what? 4 into b1 plus 1 into b power 0. Similarly 3 you can write how? 3 power b power 0. 13 you can write 1 upon b power 1, and 3 you can write as b power 0, isn't it? So this becomes your 4b. This is the 1, this is 3, and this is your 1, and this is 3. Okay, so this becomes 4. Sorry, this is b, this is b plus 3. Okay, so if I multiply this one, this implies what? 4b plus 1, that is 3b plus 9. Okay, so my b will be what? 8.
8.
Okay, so in octal number system, this is okay. In base 8 system, not octal number system, octal system, you have base 8 system. Okay, you can write like this. Okay, so let me give one more problem. Say in some number system, under root of 61 is equal to 7. Okay, some base number is 7. Okay, now here's this 7. Say I'm telling, say 10 is, this is 10, base system 10. Okay, this is in B, and this is 10 equal to 7. So find out the base. Find out the base.
So b is equal to 8.
So what I can write? Okay, I can write this number as 6b plus 1 equal to 7. Okay, 6b plus 1 equal to 49. Okay, 6b equals to 49 minus 1. So b equals 48 upon 6, 8. Okay, so b is 8. Now you have to remember one thing. Suppose this is a base 8. So for example, like I have a decimal number system which has the base 10. So any digit cannot be greater than 10. All digits will be less than 10. Okay, so here base is 8. So any number in this number system cannot have this 8. All the digits will be less than 8. Are you getting my point? What I'm saying? Like you have a binary number system that is a base 2. So it has only 2 digits, 0, 1. Okay, it cannot have a digit 2. Similarly, if you have an octal number system, you can have only digit up to 0 to 7. Okay, you cannot have 8. So at 8 is the maximum. It is if you say it is a base, so that is a maximum number. Okay, and your number system, any number which you write in this base will be less than base. Okay, so your octal number system cannot have a number 8. Okay, decimal number system cannot have 10. It has a symbol only 0 to 9. Similarly, your hexadecimal number system cannot have a symbol for a separate symbol for 16. Okay, it can have only symbols up to 0 to 15. Okay, so let me clear this point. Okay, give me a problem. For example, if I say what is the, I have 1 2 3 4 plus 5 4 3 2. Okay, so this is true in which number system? Which, okay, what is the base? This is true in which number system? So let me add this one. So if you add this one, it will give me 6 6 6 6, isn't it? It is correct. This sum is correct.
Yes, sir.
So that means this sum is equal to 666 is valid. Which number system is valid?
Decimal.
Decimal and octa.
7. This
Decimal.
is decimal is valid. Whether it is valid in octa,
Yes, sir.
octa also valid. Okay, so this because you at any base which has a higher than this one, these numbers can be base for this number system. Okay, so you can write it is, this number is valid in any number system. Okay, with base okay equal to greater than 7. This operation or this sum is true. This is true in decimal also. This is true in octa also. Okay, this is true in 7 base also. Okay,
Hexa also it might be true.
it's true. Okay, any number system which is with a base greater than 7, this sum is true. Okay, so you have to understand. So base is the highest number in any number system.
सर उसका वेट तो 16 है ना, हेक्सा का.
किसका?
हेक्सा का.
हाँ, तो उसका बेस 16 है ना.
हाँ जी, तो उसके लिए तो वैलिड नहीं है ना.
उसके लिए भी वैलिड है, सबके लिए वैलिड है. आप नंबर तो यही है ना, सम तो करोगे तो यही आएगा. तो 6 तो उसमें एग्जाम में होता है ना 6 तो. ओके, जब नंबर उसमें प्रेजेंट नहीं है देन देयर इज इशू. दिस सम इज वैलिड इन any base. 7. Okay, this number should not be greater than 7 or 7. If it is 7, if one number is 7, then it become 8. Okay, all the number combination should be less than your base. Okay, then this sum is true.
Excuse me, sir. सर जैसे हम 1 + 1 करें तो in binary number system it will give 0 and carry 1. So ये तो वैलिड नहीं होगा ना और कोई नंबर सिस्टम में, मतलब 1 0 आ गया वैल्यू तो इट इज नॉट वैलिड.
भाई आपका 1 + 1 क्या होता है बाइनरी में? 10 होता है.
यस सर, तो ये तो और किसी नंबर सिस्टम में वैलिड नहीं है ना.
पर इसका डेसिमल इक्विवेलेंट तो 2 ही है. इसका डेसिमल इक्विवेलेंट तो 2 ही है ना. ओके, हम तो डेसिमल इक्विवेलेंट की बात कर रहे हैं. ओके, है तो नंबर तो वही है, उसका वैलिड था ही उसमें भी. ओके, वो 2 है, उसमें भी उसका वेट 2 ही है. ओके, फॉर एग्जांपल अब से 1 + 1 + 1. ओके, इफ आई राइट 3 इन बाइनरी में भी 3, ये बाइनरी में कैसे उसको 1 1 1 लिखोगे? क्या लिखोगे? 1 1 0 1 1. ओके,
यस सर,
तो वो वेट तो सेम ही रहेगा. ठीक है, ये तो इस तरह का वो तो सेम ही रहेगा, वो तो सेम ही रहेगा इसके अंदर. ओके, बेस में वैलिड तो रहेगा सम. I will discuss one more problems. Okay, we'll come around. These problems come again. Okay, so now, okay, so far what we written, we have decimal number, we have decimal. Okay, decimals like 0 1 2 3 4 5 6 7 8 9 10. Okay, and I want to write is a binary number. binary number. So this will be frequently used. So you have to remember this one. 0 is 0, 1 is 1, 2 is 1 0, 3 is 1 1, 4 is 1 0 0. Okay. If you convert 1 1, you get decimal equivalent is 3. Okay. For 4 you get 1 0 0. For 5, what do you get? 5
101.
101.
101. Okay. So 2 power 1, 2 power 0, that is 1. 1 plus 2 power 1, 2 power 2. 2 power 2 is 4. 4 plus 1, 5. Okay. Similarly, if you want to write 6, that will be 110. You want to write 7, that will be 111. Okay. If you want to write 8, so 8 will be what?
1 triple 0.
1 0 0 0. 2 power 0, 2 power 1, 2 power 2, 2 power 3. 2 power 3 is 8. Okay. Similarly, I want to write 9, it will be 1 0 0 1. I want to write 10, 1 0 1 0. Okay. Similarly, if I want to write decimal number, let me write 11. Okay, let me write to 15. 11, 12, 13, 14, 15. Okay. And the binary number. Okay. For 11, what I can write? 1 0 1 1. Okay. So 1 2 3 8 11. Okay. For 12, what I can write? 12. 12, what I can write? This is 12. Okay. 2 4 8 2 4 6. Oh, 2 and 4. What is this? 2 power 1 2. 2 power 2 4. 4 and 2 6. 2 power 8. It's become 14. It's not. Okay. So what should I write? This is. It is correct. 2 power 4 4 and 8 12. Okay. 13 1 1 0 1. 13 14. So 14 will be what? What should I? How should I write 14? 1 1 1 0. So 2 plus 2 power 4 and 8 16, and now 15 will be 1 1 1. Okay. So this is 1 2 power, so 1 2 4 8, that is 15 3 7 15. Okay. So you should remember these things. Okay, because we will be repeatedly using this number. Okay. Now if your digit is only made of ones, okay, if in a binary number system there are all ones, okay, so if there are all ones, okay, so that means your number is made like this. Okay, all ones. Okay, in that case you can simply write the decimal equivalent of that number will be decimal equivalent will be 2 power n minus 1. For example, you have a two ones in binary number system. Okay, so you can add 2 here, 2 power 2 4. This will be decimal equal to 3. Okay, if you 3 ones, okay, decimal equal to 7. Okay, you have 4 ones. Okay, so you can write 4, how much? 16 6 15. Okay, you have 5 ones. 5 ones. Okay, how much? 32. 32 minus 31. This is equal to 31 in 10 number system. Okay, and so on. You can write like this. Now, okay, let me write octal to binary conversion. Okay, octal to binary conversion. So what do you mean by octal? Okay, so I have a decimal number. Okay, decimal number. So 0 1 2 3 4 5 6 7 8 Okay, and I have a binary number system. Okay, and then I have octal number system. Octal number. Okay, so octal have a seven symbols, 0. Okay, 3, 4, 5, 6, 7, 8. Okay, so binary the octal equivalent of decimal is 1 is 1, 2 is 2, 3 is 3, 4 is 4, 5 is 5, 6 is 6, 7 is 7. Okay, 8 is, if I want to write 8, what should I write? 1 0. Okay, if you multiply, it's 8 power 0, 8 power 1. Okay, it has become 8. 8 power 0, 8 power 1, 8. If you want to write 9, okay, 9. 9, how can I write it? 1 1. Okay, can you write 1 1? If you convert 1 1 into 8 power 0, okay, so 8 power 1, 1 into 8 power 1 plus 1 into 8 power 0. This becomes 8. How much? What should I write? 8 power 1 is 8, and this is 1. This is 9. Okay, so this is correct. Okay, similarly, if you want to write 10, so you can write 10. Okay, so 10 is not visible here. Let me make it this up. 10. Okay, so 10 will be what? Again, you put 1 here, 1 here, 1 here, 1 2, 1 2. Okay, if I write 1 2, that way 1 into 8 power 1 plus 2 into 8 power 0. This become 1 into 8, and this become 2 by 8 is 1 2. This become 10. So 10 is equivalent to 12 in octal number system. Is there any question? Okay. Now, whenever I want to convert this octal number system into binary number system, okay, I'll always write 3 digits. Okay, I'll write 3-digit binary number. So that means 0 is equivalent to 0 0 0, 1 is equal to 0 0 1, 2 is equals to 0 1 0, 3 I know this is 1 1, but I have to put 1 0 extra, because whenever I want to convert octal to binary, okay, always I will convert, okay, it in I will write in three binary numbers. Okay, 3 binary numbers form. Okay, so 3-digit form. So 4. So 4 is I know this is 1 0 0, so I don't need to put extra 0. 5 I know this is 1 0 1. 6 I know this is 1 1 0. 7 I know 1 1 1. Okay, then 8 is what? 8 is what? 1
0 0
0 0. 9 is 1 0 0 1. So this become now, okay, so this I don't require, okay, because octal number system, okay, we have only up to 7. Okay, octal number system we have to only 7. Okay, so if I want to convert any number system, octal number system, to binary, I require up to 7 only. So these things are not required. Okay, so these things are not required here for octal number system. Now just let me give you example how can I convert, okay, any decimal number to octal number system. For example, I have been given a number, okay, 3 5 7 4 in octal number system, okay, and this say find out its binary equivalent. Okay, so what I will do, it is very simple here, no need to do anything, just to write this number 3 5 7 4, okay, and write its binary equivalent. For example, the binary equivalent of 3 is what? 3 number system 1 1 1 or 0 0 1 1. Okay, 5 is equals to what? 1 0 1. 7 is equals to what? 1 1 1. And 4 is equals to what? 1 0 0. Are you getting what I'm doing here? You just have to replace the digit by its binary equivalent. If I want to convert octal into binary, So I have 3, 5, 7, 4 in octal, and if I want its weight in binary, simply I'll write 0, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 0. That is equivalent of this one. Okay, binary equivalent of this number. Now, if you want, you can check. Okay, you can convert this is decimal, this is also in decimal, and see both are coming same or not. Okay, so this is what, this is your octal to binary. Octal to binary. Now opposite also true.
So
You want
octal को decimal में convert करने के लिए we have to
multiply but in base 8.
yes sir.
And ये multiply base 2.
Yes sir.
Okay, now this was octal to binary. Now suppose I have to do reverse. I want to convert binary to octal. I want to convert binary to octal. Okay, so for example, I have been given a number 1011.01101 in by number, and I have been asked to convert in this octal number system. Okay, so how to do it? Okay. So again, the conversion is very simple. You just need to write 1, 0, 1, 1. Okay. Again, 0.0, 1, 1, 0, 1. Okay. Now you make pair of 3 because 3 binary digit makes one number. So you make pair of 3. You start from decimal point. You start making pair 3. Okay. Now you have only 1. You don't have any pair. So you make 0, 0 here. So you have 2 pairs now. So 0, 0, 1 is equivalent to what in octal number system? It is 1. And 0, 0, 1 is equivalent to what? 3. Again, you put point here. You start making pair from here. This is one pair. Okay. And this is on 2. So you can put extra 0 here. Okay. So fractional part, right side you can put 0. That will not affect anything. Okay. But 0 multiply anything 0. Okay. Similarly, 0 multiply anything 0. Okay. So left side you can put 0, extra 0. Okay. Now this 0, 0, 1, 1, this is your 3 and this is your 2. Okay. So now this is number
in decimal में you have right side put in 0.
Right side 0. Okay. So if I want to say octal number, this become your 13.32 in octal number system. This is equivalent for 13.32. Now, what is the advantage of this octal number system and hexadecimal number system? Okay, especially when are you in exam? Okay, and you have been asked to convert a decimal number into binary, and suppose very large number is there, 500, 600. Then you have to multiply. You have to divide by 2. You have to do successive division. Okay, you need to do it again. Then that will become your time-consuming process. Okay. अगर मुझे कोई बड़ा नंबर दे दिया है, if some large number is there and I want to convert it into a binary number, for example, say I have been given say a number, say 363, and I have been asked to convert this number into binary number. So decimal को binary में convert करने के लिए, as we discussed already, we need to use successive division method. So you need to divide by 2. So how many times you will divide by 2? This is a large number, very large number. So better to write this number first into octal number system, convert this number into octal number system, and then from octal to you can come to binary. Similarly, you can convert this number into hexadecimal, and hexadecimal to you can directly come to binary. Okay. So for example, this is 363. So I will convert this number first into octal number system. I'll divide by 8 instead of 2. Okay. So if I divide by 8, okay, how much will come? It will come 445. Okay. What is the remainder?
3.
3. Very good. If I divide by 8, there will be 4. Remainder will be 5. Okay.
5.
This remainder will be 5. Okay, so that means this 363 is equivalent to, okay, you have to go upward, 553 in octal number system. Okay, now I want to convert this in the binary. That is very easy. Replace each number by is binary equivalent, like 5. So 5 is what? 101. Again 5 is 101, and 3 is what? 011. This is binary. So this conversion is fast. Okay, now if instead of 8 you go for 2, that will take long time. Okay, similarly you can convert with 16, and then that will be more faster. Okay, so this is your thing. Okay, now tomorrow we'll discuss this your hexadecimal number system. Okay, and we'll do some more problems. So I'm stopping here. You have another class also. Okay, so thank you very much.
Thank you.
Thank you, sir.
Thank you, sir.